So in this lesson, we're going to look at function notation, and it's just a different way of writing the equation for a function that can be manipulated to help you in word problem contexts. So we know the equations from a function look like y equals, something like 3x squared plus 2x minus 7. That is an equation of a function written in y equals format. Now function notation changes that y and writes it a little bit different. And it was invented by a mathematician named Euler, who you'll learn a lot more about in geometry. But writing this in function notation, I'm going to write it like this. I'm going to replace the y with f parentheses x. And the way this is read is f of x. Okay? That's how we read it. So this is the exact same function written in function notation. And we read it f of x. And that's how it's read. Now, f is just some generic name that I come up with for the function. F stands for generic function. And x is the variable of input. So what I could do is if I have a problem context, so for example, if I'm looking at an object's height above the ground over time t, instead of using y equals, I can use h sub of t, which means height at time t. And I can come up with some relationship or some equation for that. And so this is actually the equation for an object's height over time t that was dropped from 48 feet above the ground. And so I can figure out its height at time 0, time 1, time 2, so on and so forth. So this is function notation. And I can pick whatever letter I want to help me in my word problems. For this is the name of the function, the first letter, the h, the f, that's the name of the function. And inside the parentheses is the input value. So it allows me to tailor my function to match my word problem. And one of the things we like about function notation is that if I want to evaluate a function, like if I want to find out what, let's go back to f of x, 3x squared plus 2x minus 7. If I want to find the function value or the y value when x is, say, 2, I write it like this. So this notation here in function notation doesn't mean f times 2 in the context of a function. What it means is substitute in 2 for x to find out what the value is. So f of 2 in this case is equal to 3 times 2 squared plus 2 times 2 minus 7. So that's 4 times 3 is 12 plus 4 minus 7. That's 16 minus 7 or 9. Okay? And so that's what this means. It doesn't mean f times 2. It means plug in a 2 into this function. So if I want to go back and say, well, what is something's height at 1 second? So if you're, falling from 48 feet above the ground, and you want to know how high above the ground you're going to be in 1 second, then you can plug in a 1 into this function and figure out what that is. And so then I just have to take negative 16 plus 48, which is a positive 32. And so that means at 1 second in time I'm going to be 32 feet above the ground still. Not a pleasant fall. But that's how function notation works. And you have to remember that this y and that f of x, they mean the exact same thing. It's just a different way of writing it so that I can put a context to it. Because this is some generic y. If I have like 10 distance equations and they're all y equals, that's really a problem. So I'm going to pick letters that represent my context situation. And remember, when you see the parentheses next to the letter, it doesn't mean in function notation that's times anything. It's not h times 1. It means plug in the 1 into your function. And that's it for function notation.